Thanks for coming to my talk. Welcome again to Codemotion Madrid. So who in the room is a Java developer or has programmed Java in the past? Oh, sweet. Okay. How many people are programming in a different language other than Java right now? How many of those languages are on the JVM? If you're on the JVM, okay, yeah, that's cool. Okay, so this talk is kind of two pieces. The first is about serverless computing. You've probably heard a lot about serverless so far. Arun talked about it this morning. I talked about it last year at this conference, and Hacker News talks about it a lot. In fact, there's a really good thread right now in Hacker News about how serverless computing is not saving somebody money and they're really angry, which I find is really interesting because kind of the spirit of serverless is not just about saving money, but I'll talk a little bit about that. So this specific talk is trying to understand how Java can become the number one language for serverless as well. So I will jump right in. I don't think I actually talk about any Oracle products. There's like 0 Oracle in here. I work for Oracle, so I'm required to put this up here, which basically means don't make your buying decisions based off things that I say. Kind of like don't listen to me when it comes to buying. A little bit about me. I think if you saw the keynote this morning, my intro, I've been a long-time startup founder. I joined Oracle a couple years ago by way of an acquisition of my last company. My last company was all about serverless computing. We had been talking about serverless since like 2010, and which is really strange because most people didn't really hear about it until around 2014. When Amazon Lambda came out, they kind of started driving this serverless message. But we just thought it was really like this kind of really cool marketing term. We had no idea it was going to be this entire category of computing. So these are a couple like Hacker News, Read White Web posts that these are from 2011. I think we have some earlier ones. So you can say that my team are some of the very earliest users of the expression serverless. So I apologize if you don't like it. It is what it is at this point, because it's stuck. So I think what's really fascinating about that is it's like this entire category of computing now. It's kind of at the top of the hype cycle. I think serverless, all the good technology trends go through these long hype cycles, and I think since last year I actually talked about the exact hype cycle. We're starting to come into that trough of disillusionment, so it kind of comes up through the crest and kind of goes down. And this is where people start putting posts like the one on Hacker News this morning, which is like, oh my God, it's not saving my money. Why don't we learn from the past? It's the worst thing ever. And you'll see in the thread, it's basically just a super long conversation about people who like it, people who don't, et cetera. That's, I think, a good sign that the technology is progressing. You're all familiar with Java, okay? There's almost 50 billion active JVMs, and this is according to VDC research. It's the #1 programming language in the world. It's the #1 programming language in the cloud. It's the #1 programming language. Insert new architecture here. Microservices, I think I heard it's #1. DevOps, well, I don't know about DevOps, but containers, I think it's #1. And there's a reason for that, because 80% of enterprises in this world use Java to some degree. If you were to read Hacker News, you would think that there's some existential crisis about Java, and whether Kotlin or Rust are going to take over the world, or Golang is going to take over the world. But at the end of the day, Java maintains a lot of superiority because it's just so widely adopted, and it's been around for 25 years, almost 25 years. In fact, we're just going into our 25th year here pretty soon. But there's a challenge. It's very far behind when it comes to serverless computing, and this is a survey that was taken from the serverless framework guys and gals. They do the serverless Inc., I think is the name of the company. And if you look here, if you can see at the top right corner, you'll see 4.96% of the stuff that they see is in Java, and Java 8 in this case. So the big question is, why is that? And in fact, the trend isn't really going in the right direction. It seems to be that Java is sort of stagnating. And so I guess coming from a serverless background and now working primarily, I guess by way of introduction, I work directly with the Java engineering team now. So I sit next to a lot of the architects, the JVM architects, the language architects, and I work on a team that does mostly kind of developer relations, community outreach, customer engagements, that kind of stuff. And so what we're noticing is that I wanted to really pair together my background in serverless with Java and try to understand why this is the case. I think it's a problem because there's so many developers out there that want to utilize their Java skills, but they're thinking, man, I should go and learn a new language because Java is not the language for serverless. So I think this is a problem. So why is this, and how do we fix it? What do we do about it? So the rest of this presentation is going to intro serverless, and then it's going to talk about what I think is happening in the Java world to sort of move us in the right direction. Okay, I'm sorry, you've all seen like 1,000 definitions on serverless, but I'm going to continue to show my own, which is pretty similar to what most people are saying. Serverless is all about outsourcing the undifferentiated heavy lifting. Arun this morning in the keynote talked a lot about this. It's all about doing the things that are core to your business and not doing the things that are not strategic to your business. And it turns out that a lot of the things that are not strategic to your business are dealing with hardware, dealing with virtual machines, dealing with patches, dealing with security updates, dealing with kernel updates. There's just a lot of kind of mundane details. And then a serverless architecture is where you use a lot of these different serverless kind of components, whether it's compute, storage, networking, tie those together into a complete serverless app. That's kind of what we're being known as a serverless architecture. And then at the bottom, you'll see functions as a service is typically what people refer to as serverless. That's the compute portion, or one compute option for serverless computing. And that's where you essentially take a function and you launch a service. You use somebody's service to manage your functions, and I'll talk about that. So in a function, it's basically just a few lines of code. It takes an input and produces some output. I mean, this is like fundamental computing. There's not a whole lot of kind of crazy things going on here. This is an example from the FN project, which is a project that my team started, my former team, we started at Oracle. It's a 100% open source functions as a service platform. You can take it and you can launch it anywhere you want, and you can run your own functions as a service. On-prem, we also have a downstream managed service called Oracle Functions. And this is like the most basic Java function. It's very straightforward. But then as a service, you want to take that function and you want to deploy it to something that can then manage that for you. All right, we've all heard this before. So level abstraction is going up, and we're decreasing the concerns, and we're decreasing our control over the infrastructure. That's kind of the direction we're going. So we start with VMs, or bare metal, VM, containers, and now functions. So going back to serverless, serverless is about taking all of these different components, including functions as a service, and creating applications using those. Arun had a really nice diagram of all the kind of AWS services, but there's tons of services on lots of different cloud providers that you can take advantage of to build a serverless architecture. And basically, it takes care of kind of all these things. And at the bottom, you really just want to think about your code. You want to actually write less code. And I think I have a slide here. So this is a picture from a movie that I really enjoy, and this is a scene where Paul Rudd is telling him he's learning to surf, and he says, you want to do less, do less. And then he says, do more, no, actually do less. I think serverless is all about doing less. It's about reducing complexity, trying to write less code, and just focus on the things that matter to your business. Okay, so I'm going to kind of frame the rest of the talk in these bullets. In fact, not the top one, but the serverless experience is all about no server management, pay-as-you-go, et cetera. I just talked about that. But then we've got these things here, like fast startup, small footprint, fast time to value. Oh yeah, no. Okay, let's go distraction. The first one, every provider, it's kind of language agnostic. But when you think about fast startup, everybody says Java is so slow, the JVM is so big, it's got a big footprint, it uses lots of memory. How do we use Java for serverless? It's not the right language. In fact, the thread I was reading this morning on Hacker News, one of the top responses is, for serverless, you really should be using, I think it was Node, Go, here are the languages you should be using because they're fast startup times. And so that's kind of the market perception right now. And I think that's one of the reasons that we need to overcome that as a community and as a language. So I'm going to start with fast startup. Here are some of the things happening in the ecosystem today. So there's a reason that Java has the perception that it does. A lot of it is that it's the truth. If you think about the Java virtual machine, the JVM, it's been around for over 2 decades now. And the JVM was really designed in a way where it optimized for certain characteristics. This idea of serverless or containers or things that run for 50 milliseconds and they go away, that is a new concept in the past, let's say. It's popularized in the last 5 or 6 years. The JVM has really been optimized for an out-of-the-box kind of ergonomic design such that it's the blue line. Everybody wants the orange line. The orange line is like, I have the fastest startup time, I have the lowest footprint, I have the lowest latency and the highest throughput. But the JVM is really designed around the blue line, which is like highly, highly optimized for throughput, but not optimized for startup and footprint. The reason for that is most applications that run on the JVM run for a very long time, and they can self-tune and self-optimize themselves over time. The JVM is incredible when it comes to doing that. That's why most kind of web scale shops become Java shops, because Java is really, really good at scaling. It's because the technology's been battle tested over many, many years. But again, this doesn't lend itself well to this kind of new paradigm of things that start up really quickly and then go away. The JVM isn't optimized for that. So what are some of the things that are being done in the Java world today that kind of address this issue? One thing, if you haven't heard about it yet, check it out. It's called class data sharing. Class data sharing has been around, I think, since JDK 5 or 6. And essentially what that is taking your classes and loading them into a file that can be consumed. It's basically laid out in memory ahead of time. So you're not doing this kind of just-in-time class loading. Application class data sharing, or app CDS, is where you can take more than just the standard Java libraries and actually include your application's classes. And you can essentially create these files that are laid out, like nicely laid out for memory. And so when the JVM loads up, it can just load those up from right into memory without having to do any compilation of your classes. This is something that's been around for a while, but it's been evolving with every release of the JDK. In fact, if you look at the most recent versions, JDK 10, they add application CDS, which is your own classes. JDK 12 enables a lot of this by default. I think it enables CDS by default. And then JDK 13 adds dynamic app CDS, which essentially removes some of the steps in order to take advantage of application CDS. And I know that part of the plan is to move to a place where, as a developer or as somebody who operates these things, you don't have to worry about this at all. You don't have to think about it. Today, there are some steps. By the way, all the development of Java happens in OpenJDK. So everything I talk about, this isn't like something where Oracle goes into a closed room and works on and then says, hey, here it is, take a look. This is all OpenJDK development. You can go to openjdk.java.net. You can actually just search for, I don't know the JEP number, which is a JDK enhancement proposal. But if you just search for CDS or app CDS, you can find all of the JEPs where the conversations are happening. You can actually go to the mailing list. You can see the design. We very, very much encourage anybody to get involved. It's a community effort to design and build Java for the future. So all of this is happening. And if you look at the graph on the right, this is essentially a hello world application. Its startup time has been reduced, I think, by 120 milliseconds in Java 9, down to under 40 in Java 13, which is the latest release of Java that just got announced about a week ago. You'll notice that it goes up from 8 to 9. That was because the introduction of the modularity system. There were some things that kind of raised the base latency, but that's actually been going down significantly, and it will continue to go down. So that's one very important thing to take a look at. GraalVM, if you haven't, you've probably heard of GraalVM at some point. GraalVM has a number of components. Some of those things allow you to, like Substrate VM is something that allows you to intermingle a bunch of languages together and all compiled and run on the JVM, which is super interesting. This aspect of it is called native image. And I think the Oracle booth has a presentation that one of the gals from Oracle can talk to you in detail about this. But essentially, what native image does ahead of time compilation such that in a closed world environment, in other words, you sort of know everything ahead of time about that application. So you're not using heavy uses of reflection, et cetera. You can actually make some really good assumptions there, and that does an AOT compilation, and it speeds it up significantly. In fact, now the orange line is what native image is intended to optimize on, which is all about startup and footprint. So it's a really interesting project to keep your eye on and try today. This is one of those things that could potentially change the game for Java when it comes to serverless. And then one thing that I really want to kind of impose upon everybody here is that just by upgrading your version of Java, you can get access to many, many improvements in the JVM and the language itself. If you're stuck on kind of Java 6 or 7 or 8, I apologize. Honestly, it's not as scary as you think moving from 8 to 9. The modularity system and a number of things kind of does introduce some overhead to upgrade your application. But once you're on 9 and you start moving to 10, 11, 12, 13, the list of changes in the releases is very, very small now, and because we're releasing new versions of Java every 6 months. The reason I say this is because if you look at the list of changes, if you look at Java 7, 8, and 9, you'll see like 100 what we call JEPs or JDK enhancement proposals. There's a lot of changes that go in. So every 2 to 4 years, there is like kind of this big event where you'd upgrade your application. Now it's a much, much smaller set of changes. In fact, I think in JDK 13, there was 5 JEPs. Literally, we went from 110 to 5. Behind that, though, there's actually thousands of JIRA tickets that were resolved that make things much faster and much more performant. I mention this because upgrading gets you a lot of this stuff out of the box. So it's something to keep an eye on. In fact, simply upgrading, not even thinking about AppCDS or Graal or anything else, you're getting about a 30 to 40% increase in your startup time. Okay, so that's startup, and there's a bunch of things happening. Again, all of this is happening in the open, so if you have feedback or suggestions on how we can better design the language or the JVM in order to take advantage of serverless computing, we're all ears. I'm all ears. Please come talk to me. Footprint is another thing that we talk about a lot. Footprint is essentially like sort of either how big your application and all of your code is laid out in memory or on the disk, or basically how many resources you're using. Resource usage is a big issue in quote-unquote serverless or functions as a service because you're playing in a cloud environment, and you want to be a nice citizen in cloud environments. Also, you don't want to pay for a bunch of stuff. Like if an application uses a lot of memory, the cost of that application goes up a lot in a serverless environment. So footprint's pretty important. To understand footprint, let's talk about the elements of that. Starting at the bottom, you have the operating system, of course. Then you have the JVM. Then you have the JDK itself. And then you have your application code. These are kind of the 4 elements of footprint. And to talk about each of these, let's start from the bottom. So for your operating system, there's something called Project Portola. And again, if you go to openjdk.java.net and you search for any of the projects that I talk about, Portola, Amber, Metropolis, etc., you'll find all of the JEPs that are included in this. Project Portola is all about making the JVM run really nicely inside of containers, specifically Alpine Linux. The footprint of Alpine Linux is a lot smaller than other Linux distributions, and this is really sort of geared towards smaller footprint containers. So that's something to take a look at. The JVM, I did talk about Substrate VM. So this is another aspect of the Graal VM project. It's a lightweight JVM, very fast. It's another component to take a look at to reduce the size of the JVM. But there's also lots of things happening just in OpenJDK that we can talk about as well. Specifically for the JDK, I'll actually talk about this in some future slides. JLink is something to take a look at. I believe it was introduced in JDK 9, or at least it's heavily used in 9 because of the modularity system. So I'll talk about that in the next couple slides. And then, of course, your application code. There's lots of things that we're working on to reduce the footprint, kind of what we call the ceremony of Java code. Certainly, it does take a few extra lines of Java to do what you can do in other languages. And this is because we spend a lot, well, the language architects, guys like Mark and Brian, they spend a lot of time thinking about how to design the language in a way that's going to be around not for the past 20 years, but also for the next 20 years. And so the Java team doesn't rush into changes because they know those things are going to be around for a long, long time. And one of the things that made Java extremely popular is its compatibility. We oftentimes hear something that you wrote in Java. I think we heard someone say something I wrote in Java 1.2 runs on the JVM today. That's an extremely powerful concept. And so fewer and smaller dependencies is something that we're working on as an industry. That's how to reduce your application code size. So respecting the environment is about kind of going back to this footprint thing. It's ensuring, we have this thing called JVM ergonomics, and that's essentially how the JVM handles memory and CPU constraints that sit around it. Typically, the JVM runs inside a virtual machine. Well, before it ran in a bare metal kind of environment, and then it runs in a virtual machine or maybe mainframe. And now we're moving into containers. So we need to ensure that we're respecting the constraints of what containers offer. And so respecting that environment, there's many improvements that started in Java 8, and they continue through 9, 10, and 11, and 12 and 13, in fact, to ensure that the JVM respects the container environment that it's in. And so rest assured, there's a lot of stuff that you're getting to ensure that you respect that environment. Not least of which are aspects like CPU set CPUs, runtime available processors. These are things that you can take advantage of to ensure that the JVM respects the container environment it's in so that you don't actually kind of starve out the virtual machine. These are really important things to look into to ensure that you're a good citizen of your cloud environment. Now, going back to the footprint of your application. So the Java, I'm going to kind of skip through these, but it's probably super small. Sorry. Let me just actually skip to the really exciting part. Okay. So if you look at the green, on the left side, you have 318 megs. That's essentially the entire JDK. That's all of the, basically everything you need to run Java, including the JRE, bundled into the JDK. But by using something like JLink, and you can actually, each of those steps there reduces the size of the necessary footprint to run like your basic Java application. In fact, using JLink, I believe there's an Alpine, we might use Alpine Linux in here. Actually, no, I think it's just using the JRE Slim container of OpenJDK. As you move down here, we've reduced the footprint of what it takes to run a Java application to just 32 megs, and I think we can do even better. This is just including the things that you need to run your application. I believe in this case, this uses just kind of the basic modules that you need, so basically like Java Lang, JavaNet, et cetera. There's some kind of very basic modules that it includes. Including more modules will increase the size, but you can see this is a significant delta between 318 and 32 megs. So this is really important to kind of reducing that footprint. And then again, if you go back to kind of JVM ergonomics, just out of the box, you're getting more and more support for Docker containers, and we're reducing the footprint of memory usage inside of Docker. So the last part about this is the fast time to value. One of the biggest reasons that we use serverless is, again, doing less, spending less time writing code and more time focusing on the business problem. And Java has Java has this perception that there's like a lot of kind of ceremony in it, which means that it kind of takes you longer to get to where you're trying to go. You can't just like put a few lines of code in a JavaScript and then use that as your function. It takes a little bit more boilerplate to get things done. So we're working really hard on ensuring that Java stays compatible and stays strong for many, many years to come, but we reduce that ceremony and reduce that boilerplate. So there's a couple elements to this. There's the ceremony, there's the complexity perception, and then there's the ecosystem. And those are kind of the three components I've thought of that increase your time to value when it comes to serverless. So the first language feature to take a look at is called local variable type inference. This might seem really simple and innocuous, but it's actually really, really powerful. This is a super simple example, but if you take, so you have your variable declaration on the left, and you have your expression statement on the right, and what local variable type inference does is gives you a new special keyword called var, and you can actually, it will infer the variable type from the expression on the right side. And what's really nice about this is it reduces a lot of the boilerplate in your code. Java has a tendency to kind of seem very repetitive and ceremonial, And so this is what the intention of local variable type inference is. And now we also include this for Lambda expressions as well. So this is pretty powerful. If you look through your code and you look at all the places you declare variables, it not only makes it shorter and more concise, but the idea is to make it less error prone, make it easier to read for people who are reading your code. That's really extremely important. It's not just about you as the writer, but also you as the reader of other people's code. And the idea is to put the focus, give you more of the focus around what your variable names are, so to ensure that you're naming your variables kind of accurately, and it gives you sort of more focus on what the code is actually doing. So that's something to take a look at. Text blocks was just released in JDK 13 as a preview feature. Preview features are things that we deem as basically complete, and we think that they're ready to be included as a feature. But we want to go and get more feedback from the community. Sometimes there's edge cases out there that we realize, and then we take the preview feature and we modify it. So essentially, what the preview features say is it can change. It may not, but it can, and we think it's complete. Text blocks is one of those features. So this is kind of your typical line of code for escaping some HTML inside your Java code. You can see you've got a bunch of quotations, you got some pluses, you got some escapes, backslash ns. There's a lot of kind of places to have errors in this code. What we can do is we can actually simplify that a lot by using 3 quotes. And now we've got code that looks really clean and elegant. We've reduced a lot of the boilerplate. This is actually pretty powerful if you have like any HTML or any SQL statements. If you have SQL statements, those are kind of the worst. I should throw an example up here for that. And then we've also added a new method called .formatted, formatted, which can essentially give you the power of kind of string replacements here. So we move the t.getRetweetCount and move that into the %s. That's actually also what we call deprecated at birth currently, because we don't have a better way to describe what that method looks like. But basically, it's a preview method as part of text blocks. And so you can access this today with preview features. Switch expressions is something else to take a look at if you haven't yet. Again, this is a Java 13 feature. It's definitely something where what we did was we looked out in the marketplace and we saw that most switch statements were actually expressions. You declare the variable at the top, and then you set the variable in a bunch of different cases, and then you have a default statement at the end, and you break. Now, there's a bunch of kind of places where this code can become is error prone. For example, did you cover all the cases? Did you have a proper break statement? Did you include the break statement in all the different cases? Did you have a proper default statement at the end? So switch expressions, newly introduced in 13, makes it much more succinct and gives you sort of this format. Apologies if it's kind of small. But it introduces the dash greater than, which is the lambda symbol. And it introduces the expression where you can actually set the switch statement into the variable itself, so you don't have to have a bunch of extra lines of code. There's very few places in this code where bugs can hide. That's kind of the real, and when you were writing this code, what Brian Getz always likes to say, when you were writing this code, what you were actually thinking in your head was this. And so that's kind of the idea of introducing these new features, is they're much more natural to the development of what you're thinking in your head. And in this case, we're using an enumerator, which is kind of, I don't show in the code here, but you can notice we don't have to have a default statement anymore. We don't have to have breaks because we're covering all the cases of the enumerator. And if you don't cover all the cases, or the enum, if you don't cover all the cases, then it will throw, the compiler will throw an error. So those are just some of the features that the language enhancements that have come recently. I talked about local variable type inference, also known as var. That came in 10. We've also got it for Lambda parameters. We've also got a tool for launching single file source code programs. So this is where you can just write, Java myprogram.java, and it will skip the compilation step and actually just run your code right there, which kind of also seems simple, but it's kind of powerful for like students and people learning Java, or if you're doing demos. Also, you can have a file that it's not the .java extension, and you put a shebang in there. So you put a shebang, I forget the exact, and then a path to your JDK. And then if you just do Java that file, it will automatically run that file as if it's a binary. So that's kind of a really powerful concept for if you're building like CLIs or quick tools to do things. That's something that was lacking in Java. So take a look at single file source code programs. And then I talked about switch and text. And then records, field types, and pattern matching are things that are coming in the future. All of those things have very, very full JEPs, so you can go take a look at and read about those. But again, those reduce a lot of boilerplate down significantly, and they're things that you should definitely take a look at today for using in future applications. So in terms of supporting ecosystem, this is one area that I think that Java has started slow when it comes to serverless, but we're starting to see it snowball. And what I mean by that is the Java ecosystem is just, I mean, it's huge. And it was a little bit slower to start for serverless because if you think about like, you know, Amazon Lambda, the first language they supported was Node. It was the only language they supported for an entire year. And then Java 8 support came a year after the launch of the service. With that comes, you know, but Java is a slow rolling kind of big ecosystem that's going to catch up. And so there's a bunch of things to take a look at. One thing I'm not going to go into too much detail is called Project Panama. But what that aims to do is make it much easier to work with native code, so code like that's written in C, for example. A lot of libraries out there are written in C or C++, because they're, you know, it's extremely fast running natively on the operating system. The way that we solve that traditionally is with JNI. And if you've used JNI, it's quite complex and error prone. That was because it was written a long, long time ago. And it was written that way for a certain reason. But essentially, JNI is like 9 steps. There's a slide for this. And what Panama aims to do is reduce that down to 1 to 2 steps. And that makes it much easier to work with things that are written for machine learning, artificial intelligence, big data, because a ton of stuff is written in native code, but you want to access that using Java. In fact, it's one of the reasons that, you know, Python has kind of taken off in the machine learning space or the data science space, is because there's this perception that that's like the #1 language for machine learning, when in fact they just did a really great job. That community did a really great job of wrapping a lot of the native code with Python libraries. And so that ecosystem has kind of taken off as a machine learning ecosystem. So there's a lot of effort in the Java ecosystem to catch up and put it in parity. And in fact, there's so much work happening right now to make this the future language for machine learning and big data. Also, cloud support, cloud vendor support. Java is kind of proliferating through all the major cloud providers, so that's really important. And then again, I talked about Java-based frameworks for common tasks, Java clients for all the popular APIs. This is just kind of a slow-rolling snowball that will catch up. So the ecosystem will catch up. So I've talked about all of those things. I'm here at the conference for the next couple hours. I would love to talk to people about what they think about why Java is behind in serverless. There's a ton of stuff happening in the ecosystem today. I'm online. You can find me on Twitter. It's just @Chad Arimura, my full name. I would love to hear from you. So I work directly with the language architects, the JVM architects, and we're always looking for ways to make Java kind of prepare it for not only the past 20 years, but the next 20 years as well. And so hearing from you, the community, get involved with the JDK process, get involved with the mailing list. We'd love to hear from you to understand how to design the language better. So thank you for your time.
Any question? So
good. Not good, maybe.
Just a question. It's about the GraalVM. When you saw the slides, you saw that well, it was a smaller footprint.
Yes.
Better startup, but the throughput was worse than the JVM. So the question is why?
Yeah. Well, So the short answer is that was kind of like a representation of what we think will happen if you kind of run Graal at scale. It optimizes for things to be very, very fast. So if you have a very short running application, it can work very well. The idea behind that, and by the way, that's not really based on science. Those are sort of like thoughts on how we see things progressing in terms of the optimization for these different technologies. There's a Graal expert at the Oracle booth that can probably tell me that I'm crazy for putting that together. The reason that we did say it that way is because what the JVM does really well is understand the workload over time and then optimize based off compilation of like just-in-time compilation. And the JVM is really good at kind of managing that workload over time. What Graal does is it kind of uses closed world assumptions. So it assumes what your application is going to look like and does an ahead of time compilation, gives you a binary that doesn't change, and it actually doesn't even use the JVM. It runs totally kind of independent. And so the idea there is that it optimizes for those things that run very fast with low latency, but it doesn't get the benefits of the JVM over a long period of time. So that was the idea there. Both technologies are evolving very quickly right now, so that might not be the case, in 12 months from now. So hopefully that helps. Any hard questions? Okay. Thanks.
Okay.
Okay.